Hello everyone, welcome to Logicpedia, where logic is power. Today we are going to solve Weekend Puzzle 2. Which pocket will the ball end up in? Assume that the ball is shot at a 45-degree angle directly from the corner of the table as shown below, and that it will only land in a pocket if the center of the ball meets the corner of the pocket exactly. Also, assume the surface has no friction so that the ball will keep bouncing as long as necessary. Let us represent the given scenario using a rectangle with corners A, B, C and D, where length of side AB is B and length of side BD is L as shown. Each of these corners resembles a pocket. The ball is initially launched at an angle of 45 degrees from corner B, which then bounces at the sides of the table to follow the trajectory as shown. As we can clearly see, it's quite hard to understand the trajectory of ball and to be able to conclude which pocket is it going to fall into. To make things simpler, let's place two mirrors at sides AB and CD respectively. Now, as all the collisions are happening at an angle of 45 degrees from the normal to the surface, we observe that the trajectory of the ball follows a straight path in the reflected space after collision on mirrors AB and CD. And so, we end up getting a much simpler zigzag trajectory as shown, which is very easy to comprehend. The ball travels a horizontal displacement of b units between every two consecutive collisions on sides AC and BD, and similarly it travels a horizontal displacement of L units between every two consecutive collisions on sides AB and CD. Take a careful look on the given figure to verify this yourself. If we assume that the ball travels a horizontal displacement of d units before falling into a pocket, from this visualization it's quite apparent that d has to be a multiple of both b and l. As d has to be a multiple of both b and l, we can say that d equals to x times b and d equals to y times l, such that x and y both belong to the set of natural numbers. Now also d has to be smallest such number because the ball won't continue its trajectory once it has fallen into a pocket. Now because we know that d is a multiple of both b and l and it has to be smallest such number, by definition we conclude that d is actually the LCM of b and l. Now once we have found that d is LCM of b and l, we find the values of x and y. Dividing both sides of the equation d equals to xb by the value b, we end up getting x equals to d by b. Now further substituting the value of d as LCM of b comma l, we end up getting x equals to LCM of b comma l divided by b. And similarly we get y equals to d by l equals LCM of b comma l divided by l. There is also an alternate method to calculate the values of x and y directly. For that, we consider xb equals to yl, which we know is equals to d. Now after dividing both the sides of the equation by yb, we end up getting x by y equals to l by b. Now we can reduce the fraction L by B in the most reduced form as L reduced divided by B reduced. And so finally we end up getting x equals to L reduced and y equals to B reduced. To understand this, let us consider L equals to 6 and B equals to 9. And so we end up reducing 6 by 9 to 2 by 3. And finally we end up getting x equals 2 and y equals 3. Now after finding the values of x and y, based on whether the values of x and y are even or odd, we can find which pocket is the ball going to fall into. If x is odd, the ball will fall either in pocket A or pocket C. And similarly, if y is odd, the ball will fall either in pocket C or pocket D. Therefore, if both the values of x and y are odd, the ball will fall in pocket C. We conclude this because the intersection of set AC and CD results in the element C. Now similarly, for all possible combinations of x and y being even or odd, we can find which pocket is the ball finally going to fall into. Now for demonstrating an example, let us consider a case where b equals to 6 and L equals to 10. In this case, we get x divided by y equals to 10 divided by 6, which further in its most reduced form becomes 5 divided by 3. And so we end up getting x equals 5 and y equals 3. These results can also be cross-verified in the given figure. In this case, as the values of both x and y are odd, we conclude that the ball will end up in pocket C. After going through this explanation, if you have really understood the solution, I have a few questions to challenge your understanding. The first question is, assuming that both L and B are natural numbers, will the ball always end up in some pocket for any given L and B? And the second question is there any pocket in which the ball can never fall? So think about these questions and let me know in the comment section if you have found the answers. Thank you for watching this video. If you really found this explanation useful, please like, share and subscribe to Logicpedia. See you in the next video. Bye bye.